Hi guys, so I'm going to teach you guys how to do Epsilon NFA to NFA. So basically, Epsilon NFA means no input symbol is not required to go from one state to another, and epsilon is enough. So before, in the previous things that we've learned, you have to have any input symbol in order to go to the next state. But for Epsilon NFA, you do not need to have an A or a B, only an epsilon is enough for you to go to the next state. Okay, and epsilon closure means it's the set of states. So it means from one state, how many states can I go to where the input is epsilon? So from this state, from Q0, how many states can I go to where only this input is epsilon? So from Q0, you can go to Q0, you can go to Q1 and Q3. Okay, so we're going to take an example for epsilon NFA to NFA, normal NFA. So here we have Q0, Q1, Q2, and Q3. So our first step is to find epsilon closure. So in order to do that, we're going to take this rule into consideration. So from Q0, you can go to Q1 and Q3 using epsilon. So we're going to write Q0, and we're going to write Q0, Q1, and Q3. So our next state is Q1. So from Q1, I can go to Q3 using epsilon. So then I'm going to put Q1 and Q3. Now, when you see Q2, there's no epsilon going to Q2. So in this case, we just write that variable. And also Q3, since we only have Q1 going to Q3, but from Q3 we don't have any epsilon going anywhere, we just write Q3 here. So the first step is to find epsilon closure for epsilon NFA to DFA. Now, the second step is to create the transition table for this diagram. So you guys know how to create a transition table, right? But what we're adding here extra is epsilon. Okay, so you usually write all four of the states on the left-hand side, and whatever input is here, you write on the top-hand side. So here we have Q0, Q1, Q2, Q3, which is your state, and 0, 1, and epsilon, which is your inputs. So Q0 and 0, it goes to Q0 since it's a self loop. Q0, 1. Q0, 1, there's nothing, so we just leave that empty. Then Q0 epsilon goes to Q1, and you keep filling the table likewise. Then our next step is we have to create a transition table for this diagram. Okay, so you guys can take a screenshot or draw that diagram on your papers so you have it for reference. So you're gonna have 5 headings on the top. The first one is going to be state, epsilon star, which is closure, input, and then the transition table value, and then epsilon star again. So we're going to start from Q0. So what you're going to do is you're going to look back here. So epsilon closure for Q0 includes the states Q0, Q1, Q3. So you're going to write the same right here. You're going to write Q0, Q1, and Q3. And you're going to do this 2 times. Why? Because other than epsilon in this table, the only 2 other inputs we have is 0 and 1. So you're going to do that. So since it's only 0 and 1, so since it's only 0 and 1, you're going to write 0 and 1. And you're going to do this for the same thing. So here, Q1, the epsilon closure for Q1 is Q1 and Q3. So you're going to write Q1, 0, Q3, 0, Q1, 1, Q3, 0. So for Q2 and Q3, the states are Q2 and Q3. So you're going to write Q2, 0, Q2, 1, Q3, 0, Q3, 1. Now, transition table. How you're going to do this is you're going to do this based on the first transition table that you did. So So Q0 to 0 gives the value Q0. Q1 to 0 gives the value Q2. Q3 to 0 input, you get the value Q3. Okay, so you keep on doing this till you fill up this value, the TT value, which is a transition table value. So once you've done this, you have something called, again, an epsilon closure. So how you're going to figure out this epsilon closure is, again, based on this table right here, or these four things right here. So Q0 is right here. So Q0's epsilon closure is Q0, Q1, Q3, right? Q0, Q0, Q1, Q3. So using these four, you're going to fill up this. So for Q2, it's Q2. For Q3, it's Q3. Since there's no value for this, it's again no value. So you're going to keep doing this until you finish this. So once you finish this table, you're going to go to the NFA transition table. So this right here was specifically the Epsilon NFA transition table. And since the question is asking you Epsilon NFA to normal NFA, we're going to now draw the NFA transition table. So how you're going to take this one, we're going to do the first two as an example. You can do the rest too for yourselves. So Q0 with the input value 0, right? So we're going to go back up here. Okay. Q0 with the input value 0. So you're going to take this into consideration, these three. So when you take these three, you're going to go to the last. You're going to take the union of all these three. So the union of all these three is going to be Q0, Q1, Q2, and Q3. Okay, so Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3. Okay, so now we have Q0 to the input 1. And Q0 to the input 1, we're going to take all of them. So why Q0 is because the state right here is Q0 and the input right here is 1. So when you take all of this is just nothing. There's nothing there. So we're just going to put that symbol, and we're going to put that symbol right there. Next is Q1 to 0. So Q1 to 0. So you're going to take the union of these two. And the union of these two is Q2 and Q3. And this is when the input is 0. And we're just going to take Q1 when the input is 1, which is going to be nothing. So this is what happens when the input is 1. So Q2, Q3 for 0 and nothing for 1. So we're just going to write that like that. And as always, you have to draw the final diagram based on the NFA transition table, not based on the Epsilon NFA table, but based on the NFA transition table. So to do that, you'll write all your four states, and then Q0 to 0 goes to Q0, Q1, Q2, Q3. So I've drawn a line to Q3, I've drawn a line to Q1, and I've drawn a line to Q2. So based on that, that's how you fill the diagram, and that is Epsilon NFA to normal NFA.